Okay, so we are starting our first topic. It is the rectangular coordinate system and graphs. Um, as I said it, this everything is going to be recorded, and this is our first lesson. So the rectangular coordinate system, it is something that a foundation for everything that we're going to be doing. So first thing first, what are the things that we need to know, and what are the concepts? If you are able to see this, please let me know.
Yes.
Thank
Yep.
you. All right. If anything is sloppy or something, please let me know. I'll try to be as neat as I can. All right. So some of the things that we need to know. Do, 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 do. So the rectangular coordinate system. So we are looking at chapter 2, section 1. So what are the things that we need to remember? The horizontal axis is known as x-axis, and the vertical is known as the y-axis. Right here, anybody remember what did we call this? Where the two x-axis and y-axis cross or intersect, what do we call that? So the values 1, 2, 3, 4, 5, and 6, -1, -2, -3, -4, -5, -6. So on the right side, it goes to positive infinity. On the left side, it goes all the way to negative infinity. Vertically, if we go ahead and say 1, 2, 3, and 4, and the same thing, it up goes all the way to positive infinity. -1, -2, -3, -4, and this also goes all the way to negative infinity. So we have our x-axis, our y-axis, and the arrow indicates that the graph is always continuing all the way to positive infinity and negative infinity. So things that we need to know, this is known as first quadrant. This is known as counterclockwise wise. This is second quadrant. And this one is third quadrant. And this is the fourth quadrant. So all of them are a little bit different. In the first quadrant, all our coordinates, which is every point that we have, has all my x's and all my y's are going to be positive. So if I say my coordinates, x values are positive and the y value is also positive. In the second quadrant, x values are, I'm going to just, let's go ahead and copy this a little bit easier. And we repeat. I have x and y on the left side. I also have x and y on the third quadrant, and I have x and y on the fourth quadrant. All right, things that we need to remember. On the left side, or on the second quadrant, the x values are negative and the y values are positive. On the third quadrant, both x values are negative and the y values are also negative. On the fourth quadrant, x values are positive and the y values are negative. So which means all of them are different depending if I say what is the behavior of x and y. On the third quadrant, both of them are going to be what? Negative, negative. And what's the behavior of x and y in the second quadrant? Would be x would be negative, y would be positive. And based on that, we are going to look at some of the names. So the names is what is the first quadrant, second quadrant, and those are the things that we need to know. Also, what is the axis, x-axis, and y-axis is definitely that we need to know. Another one that we need to know over here would be where it crosses. That is known as, if I just go ahead and point and do, Let's go ahead and say it. There you go. That is known as the origin. The origin, the x value is 0, the y value is also a 0. So that is where the two values cross each other. So a little bit on a neater side, I'm just going to show you guys how do we plot an x and y axis. Each coordinate has x coordinate and x and y coordinate. It's a little bit um, easier to think of intersection points. Where the 2 point intersection, it is what we are going to refer as a coordinate. Any questions so far? Please say something. If not, I'm just going to scroll. Again, this is recorded, being recorded. So if anything is not clear, please rewind and watch. At the same time, if I am rushing, please slow me down. Okay. Okay. So what would be the answer for first one, or A, B, C, and D? What would be the answer? It says state the quadrant for each coordinate given. Somebody help me.
A would be in the second quadrant.
Quadrant. So it would be, so the x value is
-3.
the y value is
Positive.
positive. So that would be second quadrant. And B would be what? So go ahead. Negative.
B would be in the third quadrant.
Third, B would be third quadrant, which is going to be negative. Negative should be in the third quadrant. So this is going to be, okay. I'm listening.
Oh, and C would be fourth quadrant.
C is fourth quadrant because fourth quadrant, everything is, x value is positive, the y values are negative. So this is going to be fourth quadrant.
And the last one would be first quadrant.
Okay, and this one will be first quadrant. Because everything is positive in the first quadrant. So this is, again, it should be a refresher. I don't know your background, so whether you have seen this last semester or on your senior high school, whatever, it should be a refresher. I don't think there should be a new lesson, but we're still going to approach it like that. If there is anything that's not clear, please let me know. Moving along. I do not erase anything, so if we need anything, I would just scroll up and let me know. Can you guys see the grids?
Nope.
The grids, it's not visible?
It's visible.
Oh, you say yes or no?
Yes, it's
Oh.
visible.
Gotcha, thank you. All right. There. So the way we do this is we have x and y. Okay, so with this, for the x, what do we do? It is let's go back. Hit horizontal. So it is horizontal move or number of units from the origin. But what do we say? It's going to be if it is positive, we go on to the right. If it is negative, we are going to the left. And I'll explain that one a little bit if it is not clear. For the y, it is going to be vertical move. So from the destination of x, wherever I stopped at x, then I'll be going up or down. If it is positive, I'm going up. If it is negative, I'm going down. So if we use some example, let's go ahead and say, how do I plot negative? Okay, -3 and 4. So -3 and 4 would be, again, according to what we are talking about over here, it would be it is horizontal number of units from the origin. So from the origin is exactly right in the middle right here. From that, I am moving to the right or to the left. All right.
To the left.
It would be going to the left because it's negative. So I'll go 3 steps to the left. It would be 1, 2, 3. And then once I get to the destination of x, then I'll be moving up or down using a vertical movement, number of units from the destination of x. So at this time, I have a positive number, so I'll be going 4 units up. So it would be 1, 2, and then 3 and 4. So this would be my coordinates. My coordinate over there would be x is -3, y is 4 would be the right way to plot my coordinates. Any questions so far? I need everybody's participation.
Not at all.
I got a question. Okay, so just imagine like the grids does not exist. So do you do it on the line?
If the grid does not exist, then I will have to give you a grid by pointing the numbers. Like the first example that we did earlier over here, when I did over here, I wrote the numbers, right?
Yeah.
It should be clearer like that.
Okay.
Okay, so sometimes they will give us grids at the end. Again, a little bit outside of our topic, but it's a good question, how to read graphs. If I give you, I'm hoping these grids are visible to you guys. If the grids are visible, and just So the way to understand or the way to read a rectangular coordinate system if is again depending. If nothing is written, let's go ahead and call this one A. We have an A and B and C, right? If nothing is written, I can assume this is going to be 1, 2, 3, and this is going to be 4. This is going to be 1, 2, 3. This is going to be -4. This is going to be -3. So if they didn't write anything on it, automatically every grid is going to represent one unit. But if they say, let's say over here, let me move this one, that way it falls exactly on the grid. Okay, as an example, this one, if they put that, that, and they say, so by giving us, even though I'm seeing each grid, but horizontally, I see the number 100. Vertically, I see 75. So which means each grid automatically is represented by what? It's represented from here is going to be 25, 50, 75, 100. Does that make sense? Over here would be 25, 50, and 75. Sometimes they will give us like this. We would say -16, +16, and then this will be, let's say, 9, -9. So horizontally, each grid will be representing 4, 8, 12, and 16, -4, -8, -12. Vertically, since it is the top number is 9 and the bottom number is -9, and I can only see 3, I have to divide that one. That would be 3, 6, 9, -3, -6, and 9. Again, a little bit outside of our topic, but that's a way to read it. Does that make sense?
Yes, it makes sense.
Gotcha. All right. So just to move a little bit faster, I know we are a little bit running out of time. So how to find the midpoint between two given points. So how do I find the midpoint? Again, if we go outside of our topic, if I give you what's the midpoint between 4 and 10, then you say, okay, from 4, I'll come once from 4 to 10, what's the midpoint? I'll come over here, I'll come over here, that would be 5, that would be 9, over here would be 6, over here would be 7, 8, over here would be 6, and then the midpoint for both of them will be like 7, right? So that would be the number that they're going to be in between. But vertically, the same thing, we can do that, but it wouldn't be ideal if we have to draw everything in that format. So there must be a formula. So in other words, if I give you a point over here, let's call this one A, and let's go ahead and say another point over here, B. What is the midpoint between those two values? So -1, -2, -3, -4, -5, -1, -2. So this is -5 and -2. And B is 1, 2, 3, 4, 5, 6. It is 6, comma, 1, 2, 3. It is 6 and 3. So what's the midpoint for that? So the midpoint formula is given by it is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So it's a coordinate, and that should be my answer. So in other words, I have to label what is given, A or B, it doesn't matter. I have to label one of them as x1 and x2 and y1 and y2. I have to label them. So you can skip it, but that habit will follow you. If this is x1, this will be y1, and this will be my x2 and y2. So if we apply that, my x1 is -5 plus my x2 is 6, the whole thing divided by 2, comma, my y1 is -2 plus my y2 is 3 divided by 2. So if I simplify, what do I get? -1, -5 plus 6 will give me just +1 over 2, comma, and then what do we have over here? Oh, the same thing. We have 1 over 2. So the midpoint for these 2 points is going to be when x is 1, y is 1, but it's not 1, it is a half. A half of right here and a half of over here, the coordinate will be right there. So the midpoint for the 2 points is going to be located right there, which is going to be x a half, not negative, sorry. X a half, and y is going to be also a half. So the 2 points that we were given originally from the left side and the right side, how do we find the midpoint? The midpoint is by adding the 2 values for the x's and divided by 2, the 2 values of the y's and divided by 2, that will give us our midpoint. So it doesn't matter how ugly it is, then we should always be able to answer that. Let me see if I can do this a little bit neater using Desmos. We had -5, -2. Please confirm if you are able to see -5, -2, -2. Da, 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 dee, da. That was our first point. And the next point was 6, 3, was it? We had 6 and 3. 6, comma 3 was the other point that we were given. And we said the midpoint that we found was, it was 1 over 2, comma 1 over 2. With the coordinate over there, come on. Let's be friends, comma, and 1 over 2. Does that look right? The midpoint between that and that should be, the midpoint will be right there. And if I label it, and then it was a half and a half, and that's what we have. Is this clear?
Clear.
Okay. I don't mind doing more examples. Please let me know if anything is not clear. Okay, the next one that we need to do is distance in the plane. So distance in a plane is, again, on a given x and y axis. How do we find, if it is horizontal axis, doesn't matter. Okay, if it was horizontal, what's the distance between 2 to 8? Oh, I would say I'll subtract, and I would say it's the 6. If it is vertical, 2 points, then I say, what is the distance between 1 to 5? I will subtract, and I will say it is 4. But if it is diagonal, what do we do? In other words, sometimes they will give us, I think not sometimes, most of the time is going to be diagonal. Let me go ahead. This is where we introduce, I can do this. One, two, three, four. 1, 2, 3, and 4. Did I do it right? 1, 2, 3, 4. Okay. Anybody remember this? This will be considered a right angle triangle. If it is a right angle triangle, we introduce the concept that is known as the Pythagorean theorem. The Pythagorean theorem tells us we label one of the sides as A, label one of the sides as B, but definitely the longer side will be always a C. It doesn't matter, A and B, if you swap them, it doesn't matter, but the longer side is going to be always C. And Pythagorean theorem says if we have A squared plus B squared is equal to C squared. So based on that one, we should be able always to solve what is the distance of each unknown side. So as an example, if I say the distance from here, it's 1, 2, 3. If I say A is 3, and the distance on the horizontal, if it is 1, 2, 3, 4, if this is 4, how do we find our answer? A would be 3 squared plus B would be 4 squared is equal to C would be the unknown, C squared. 3 squared is going to give me 9, 3 times 3. 4 times 4 will give me 16 is equal to C squared. 9 plus 16 will give me 25 is equal to C squared, but we're not looking for C squared, I'm looking for C. How do I get rid of squared? I would take the square root of that side, I would take the square root of that side. Whenever we take the square root, we usually supposed to say plus or minus, but we'll cover that one when we get to chapter 5 and the latter part of chapter 2. And so square root of 25 would be just 5. And since we are dealing distance, the distance is always positive. We're not going to say positive 5, negative 5. And then our answer will be C is equal to 5. So that is the way we solve it if it was just A squared, B squared, and if it was given in a triangle format. But when we are dealing with distance in the plane, we are looking at the X and Y axis, the coordinate system. In the coordinate system, draw. Okay. If I say, what is the distance between two. What's the distance between this point and that point? So if I say this is, as an example, 1, 2, 3, 4, 1, 2. So this point over here would be -4, -2. On the right side, 1, 2, 3, 4. Over here, 1, 2, 3, 4. Over here would be +4, +4. So what is the distance between the two given points? So in other words, what I have to do is, since it is diagonal, it's almost trying to find the distance between this point and that point. So if it was diagonally, then I have to use a Pythagorean theorem. the Pythagorean theorem, which means over here, I need to know the distance from here to here. I need to know how the distance of x. Vertically over here, I need to know the distance of the y. But since I don't know, then I have to go ahead and do my imaginary triangle. You don't have to draw this, but I'm just showing you how this is related. So basically, we are looking at a triangle. So, which means if I can, my goal is to find what is this distance, but if I try to see horizontally and vertically, then it looks like it's going to be a Pythagorean theorem is going to be applied. So if I know the distance horizontally, if I know the distance vertically, then I can go ahead and find my answer. So the distance formula is given by all right, scroll a little bit. First, I need to know my distance for the x. So the x is given by, so I need to know what is x1 minus x2. So if I subtract the two x's, then I will find the difference of the x's. But at the end, I have to square it. So once I find the answer, I'm going to square it. Then I'm going to be adding it to the difference of the two y's. It's going to be y1 minus y2. It doesn't matter. Some people, they write y2 minus y1. It doesn't matter as long as we're not scrambling the x and y in one bracket. We should be okay. All the x's is the difference of the x's, the difference of the y's. And what do we do to that one? Also, I squared it. Then it was going to be squared. Then it was going to be c is equal to c, but we don't call it c. We are going to call it d, which is distance squared. So I'm not looking for distance squared. At the end over here, if you remember, we took the square roots. If I take the square root of both sides, the square root of that side and the square root of that side, distance formula is given by x minus x1 minus x2 squared plus y1 minus y2 also squared, and everything is square root, and that will give me the distance. Okay. So the good habit over here would be label your x1, y1, x2, y2. So if I try to do that one, what is my x1? My y1 would be x1 is 4 minus the formula belongs, the negative belongs to the formula, and my other number is -4. Close that parentheses, and then I have to square it. Our next number is 4 and 4 plus y1 is 4. The formula has a negative sign, and y2 is -2. And I'm supposed to take the square root of this, and I would say it is equal to d. So let's give ourselves a little room. Okay, so d is equal to 4 minus negative, negative, it becomes positive. So it's going to be 4 plus 4 squared plus negative, negative, it becomes positive. 4 plus 2 squared, everything is square roots. D is equal to the square root of what? 4 plus 4, it would be 8 squared plus 4 plus 2 is going to be 6 squared D is equal to 8 times 8 would be 64 plus 6 times 6 would be 36. D is equal to 64 plus 36 is going to give me 100. 100 is a friendly number, so the square root of 100 would be 10 would be my answer. If the radical is not a friendly number, if it is a square root of 1, a square root of 4, a square root of, in other words, if it is a perfect square, I expect you to write it 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6, 6, 7, 8, 8, 64, 9, 9, 81, 10, 10, 100, 121, 144. If it is any of those numbers, we know they are going to be a perfect squares. We can go ahead and write it down. As an example, square root of 100, our answer was 10. So that is okay. But if it is not a friendly number, then you can leave it, which means if my answer when I try to solve, if it was square root of 23, then you can leave it as square root of 23 because it's not a friendly number. It's a decimal number, and we're not looking for a decimal number. I'm listening.
So pretty much it goes with like even numbers in a way.
Not even numbers. This is just like, this is 1 times 1, right?
Yeah.
This is 2 times 2, 3 times 3. These are known as perfect squares, right?
Yeah.
So what is the square root of 9? My answer would be 3. This is like 5 times 5 will give me 25, but the square root of 25 would be 5. Or 7 times 7 is going to be 49. What's the square root of 49? I get back to 7. So in other words, when I try to, even if you don't memorize it, right? Plug it in your calculator. On your calculator, if it gives you a decimal number, ignore the decimal number. Just go ahead and leave the number as a radical form. In other words, let's say on our calculator, I try to find the square root of 125. Is that a friendly number? No, because when I do that, it gives me, if it was 121, then I would have been able to leave it as that. 121, oh, that's going to be 11. But 125, I will leave it as this, as square root of 125. If it is 121, I expect you to write 11. Does that make sense?
Yes, it does.
So again, honestly, if anybody did the work like this, I wouldn't even be that picky when it comes to the final answer, how it is written. Always, I would look for for you to follow the instruction properly. But again, I'm not going to be that picky. Oh, you left it in decimal format or as a radical. I don't think that would be the bigger deal. My bigger deal is if I'm talking about distance. If I'm talking about distance, were you able to recognize the distance formula? And then when we are talking about midpoint, were you able to use the midpoint formula? That is where I'm concerned. Does that make sense?
Yes.
Okay. All right, moving along. If there's any questions, please stop me. Okay, insert another plane. Like Okay, so everybody can see the green line, right?
Yes.
Yes.
Okay, so now the green line, it is crossing the x-axis and it crossing the y-axis. So when it crosses the x-axis and the y-axis, these are known as, they are called intercepts. So they are intercepts. What are intercepts? Where the graph crosses one axis is called, it is intercepting that axis. So a special name for this one would be, since the vertical line is y axis, this is known as y intercept. Since this one is crossing the x axis, this one is known as x intercept. So there is a behavior, and when it's crossing the x-axis, when it's crossing the y-axis, one of them is 0. In other words, if I'm looking at the coordinate, it would be, over here would be 1, 2, 3, 4. The coordinate over here would be x is 0. The y value is 2, 0, 2. For the y-intercept, what do I know? The y-intercept always x value is 0 because it is crossing the y-axis, and when it is crossing the y-axis, it doesn't matter at that point. The x value is always a 0. For the x-intercept, 1, 2, 3, 4, 5, 6. This is -4, and the y value is also a 0. So the x value is -4, the y value is a 0. So when we are talking about x-intercept, what do we know? X-intercept always is the y is 0. Whenever we talk about y-intercept, x is 0. So as an example, if I'm giving you a question, and let's see, if I say 2x plus 3y is equal to 6, find x and y intercepts. I think the proper way should be written like this way. Find x intercept and y intercept. So if the given question is like that, and as an example, 2x plus 3y is equal to 6. Now, we need to close this, close this, close this. The question I gave you, it was 2x plus 3y is equal to 6. So what is the x-intercept? What is the y-intercept? X-intercept is 3, 0. What is the y-intercept? It is 0, 2. Okay, so this is, we already saw the answer. But if I don't know what the answer is, and if I'm not using a graphing calculator to answer this question, how do we do that? So for x-intercept, what do we do? Set y is equal to 0 and solve. On the right side, for y-intercept, set x is equal to 0 and solve. So if I'm a little bit lazy, actually I'm lazy, so let me copy and paste this. So what do we say over here? Set the y equal to 0, which means I'm not going to use this y over here. I'm not going to use the x over here. To solve for x-intercept, what do? We make the y equal to 0. And then to make over here, we do the x is equal to 0. So if I try to solve 2x, anything times 0 becomes a 0 is equal to 6 divided by 2 divided by 2. X is equal to 3. So what is my x-intercept? my x-intercept is when x is equal to 3. What does that mean? When x is equal to 3, y is 0. That is my x-intercept. Y-intercept would be 2 times 0 is 0. 3y is equal to 6 divided by 3 divided by 3. Y is equal to 6 divided by 3 would be 2. My y-intercept is 2, which means when x is 0, the y value is 2. Let's confirm if this is true. We have 3, 0 and 0, 2. Over here, we have 3, 0 was our x-intercept, and then 0, 2 was our y-intercept. So some questions, it doesn't matter how the questions are written. All we have to apply is this step. If I'm trying to find x-intercept, I will make the y 0. If I'm trying to find the y-intercept, I will make the x 0. So it is vice versa, whatever question that you are looking at. All right, let's go. All right, All right, some questions that we might have, let's say, y is equal to 3x plus 9, it doesn't matter. And then y is equal to negative 2 over 3x plus 4. So the same thing, find x-intercept, find y-intercept. For x-intercept, what do? For x-intercept, set y is equal to 0 and solve. So it would be 3x plus 9 is the question. What am I changing? The y value, I'm going to make it a 0. Take away 9, take away 9. Negative 9 is equal to 3x divided by 3 divided by 3. Negative 3 is equal to x. So what is my x-intercept? X is negative 3. As a coordinate would be when x is negative 3, y is 0. So that would be my x-intercept. For the y-intercept, what do? For y-intercept, set x is equal to 0 and solve. So I have y is equal to 3 plus 9. So what am I changing? The the x value becomes a 0. So what do we have? Y is equal to anything times 0 is 0. This becomes a 9. So when x is 0, y value is 9. So if I graph that, I don't know, just like a sketch kind of stuff. Negative 3 and 0 would be negative 3, negative 1, negative 2, negative 3. Negative 3 would be right here. That would be my x-intercept. 0 and 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 would be somewhere here. So if I graph this, I should be seeing a graph. And not the sloppy one over here. I should be seeing a graph something like this to show me that at 9 there is a y-intercept, and at negative 3 there is an x-intercept. So let's do this quickly. Y is equal to 3x plus 9. Just for your eyes, y is equal to 3x plus 9. So my x-intercept was at negative 3. My y-intercept was at 9. So not a big deal. If we apply that, we should be okay. For x-intercept, we always make the y 0. For the y-intercept, we make the x 0. Okay, just a recap to come back to what we're doing over here. So based on our syllabus today, we are covering this, the rectangular coordinate system and graphs. So these are on page 84. We have a homework, which is from number 9 all the way to that, which is number 9, 12, 17, 22, 27, and 29, and 36. And that homework number 1, is due on Wednesday at noon. It is going to be, so Tuesday, you should be able, anything that you're not able to do between today, or if you're not understanding, you should be able to ask questions to Mr. Jarvis. You should be able to reach out to him by Tuesday during your class and so on. But if you are looking at this video, you should be able to answer the question or anything that's not as a assigned as a homework. The book that is right here, don't go by what's highlighted. It is from the previous class. So our assignments, as an example right here, it says 9, 12, 17. It would be number 9, 12, 17, and what do we have over here? 22, 27, 29, 22, from 27 all the way to 28 and 29, and number 36. 36 is also right here, somewhere here, and 36. Okay, so we covered most of the material. If there's any question, I would love to know. And if I student preview, all right, you should be able to see this. For the homework, all you have to do is click on the homework, and this one tells you the due date, which is going to be by Wednesday the 19th at 12 p.m. is going to be due. And then the way we submit is going to be, you can go ahead and attach a picture of what you are like you can take a picture, make sure it is clearer. By the way, I just want to be a little bit clearer how we submit our homework. I don't need to guess what homework that you are submitting. So this is the format for all our homework. So if your whatever that you are submitting, top should have your name, section. As an example, this will be chapter 2. 2.1 is the assignment and the date. Of course, what question that you guys are working, number 9, number 12, whatever, it's fine. But I want to see on every assignment on the top, I want to see first, I want to see your name, 2, the section or the assigned homework, and 3, the date. Any question?
I actually have a question. So, is it going to be available to submit it? Because only thing it doesn't give you the option to upload.
It should though.
Because I'm on it right now.
Attempt.
No, like you can copy and paste, but you can't upload.
And the view assessment over here.
Hold on, let me go back. Yeah, that doesn't give me that option.
This doesn't exist on yours?
Nope.
Are you looking at it on a phone or?
No, I'm on my MacBook and it doesn't give me that option. Because right now it just says, use the space to build your submission, and then it says you can add images here, but I would have to.
If you click on that text.
Hold on, let me see.
Once you start to try to write, these options should show up.
Okay, there it is.
It is there?
Yep, I got it.
And then I think attachment is right there.
Yes.
Whatever attachment that you are, I prefer like a picture.
Mm-hmm.
If you try to attach, then it should be able to And if you want to add, no, this is for me to add anything. But under attachment, you should be able to attach any pictures in a picture format, and that should be okay. All right, I'm not going to hold you guys. I'm going to stop the recording for now. Um, just in case. I see I don't have that access. All right. Just to have it on this video. Uh, was it Heather that asked about tutoring, or who was it? I'm sorry.
Yes.
Okay.
How do you like make an appointment and all?
All right, let me see if I can get into that. See, my account is an instructor account, so I'm not sure if. Okay, so on the portal, you should be able to see Starfish. Actually, we're going to be sending out an instruction how to make the appointment. Okay, so click on a Starfish. When you click on a Starfish, it should show you your landing page. Your landing page, it should look like the people that you are connected to. I think it's going to be, it should say My Success Network. Okay, it says My Success Network. My Success Network should have all these people, depending academic coaching, advising. If you are like in any business, any office is listed under My Success Network. So if you are trying to make an appointment for virtual tutoring should be some more writing over here for writing. It is somewhere there, and why is not responding to me today? Tutoring, okay. I think for you guys it says virtual tutoring appointments. That's the way you guys are going to be seeing it. If you click on that one, it should show you who are the tutors that are available. And most of the pupils, they're next to their names. It shows you what subject that they're able to tutor. As an example, as Mr. Jarvis told you guys the other day, yesterday, he also tutors here with us at the center. So if you click on, I see, since I'm not student, I see email and view profile. If you log in and try to do this right here, one of the options when you click over here, it will be schedule. Under schedule, you should be able, and then when you click over there, it should show you all his availability hours for next week and so on. So again, don't panic. This class is a little bit on a slow pace, but at the same time, if you need assistance, we'll do it together.